Good morning, good afternoon, and good evening, and welcome to Energy Speaks Back, powered by Hark. My name is Paul Webb, and I'm your host. And weekly, I present to you energy experts from around the world. And today we are in the US and we're in Venice at the same time. Our purpose, as always, is to provide a good understanding of energy management knowledge from around the world, which is available today for us to deliver energy savings that impact on our planet. And before we really get into this intriguing interview of why we're split across the world today, I want to recognize our sponsors. And our sponsors are made up from Clean Energy Revolution, who provide knowledge and networking throughout the renewable world. B2B Energy, who provide energy management and look after organizations' third largest expense. Hark Systems, who are renowned for their energy software. EcoSync, who are renowned for their energy solutions. We would like to welcome Alexis Energy from Australia, who are providing initiatives around power management. Led by Vision, who are a LED and a controls organisations in the UK. Watts for their electronics and EV transition strategies, and Black Carbon for their waste to energy. And lastly, I would like to recognise our certificate partners, who are Ester Energy, who provide us with CPD certification, and they provide us with the Certified Global Energy Expert certificate. So welcome to episode 54 of Energy Speaks Back, powered by Hark. And our special guests today are from the compressed air world. And you're going to hear some really interesting insights to how you can manage compressed air and how you can look to save energy through better management of these systems. And both these experts today have significant design, commissioning, and management skills around this technology. So without any further ado, I give you Daniela Kursinitsky and Elvira Brakova. Good afternoon. And I'm hesitating because I have no idea what time of day it is for you guys. So I'm guessing it's good morning, Dani, and it's good afternoon, Elvira. Is that right?
Correct. It is 7:48 a.m. here in Chicago area.
And it's beautiful afternoon in Venice. So hello from beautiful Italy, everyone.
Brilliant. So it's very difficult for me to, when I'm interviewing more than one person, because we've got this one-to-one rapport. So I'm going to try my best today. So we'll start with you, Dani. You're obviously in the US. Nice to meet you. Can you give us some background for the benefit of today, for me and for the audience?
So the benefit of today is we're going to be talking about compressed air, specifically the demand side. When people think compressed air savings, they go straight to the compressor. Like the big compressor, update it, make sure it's modern, all that stuff. Or they go straight to the leaks. So any of the leaks, of course, you want to fix those. But what we find gets often missed in this energy optimization process is where you're actually using the air. So a lot of people think that that's how much it costs to create a part in production, that you have to use this much air and that's it. Like you don't have a choice, really.
Tell us about your background.
So me as a person, I've been with a company called Sylvent for 6.5 years. Although I started off after college, I actually have a degree in wildlife, so animal degree. So I have no idea how I ended up here. It was a lot of life events that happened. And then I was an auditor for Del Monte Fresh Produce. So that kind of got me into the world of production, fresh cut, things like that, and into sales. And from there, I was looking for a different job. There, I was traveling a lot every week. So I was looking for a change. And then I think I accidentally applied to Sylvent. And they called me and I said, I don't know compressed air. Like, do people even use that? I sell fruit. I know people eat fruit. You know, I'm not sure. So, of course, we all know my decision because I've been here for 6.5 years now.
Wow.
I came to Sylvant, and a lot of people use compressed air blowguns and nozzles and air knives. Almost all manufacturing has to use it for cooling, cleaning, drying, moving product, for if they're making anything. So that's where I got into this, and I love it. I'm obsessed with it. I have a favorite air gun now. Didn't know that would be a thing. So,
So considering you come into
but
this
I love
by
it.
accident, you've now grown the passion for that.
Absolutely. And I mean, the people that I get to meet, I get to go into, have you ever seen like how it's made on TV, like where they go through the production process?
Mm-hmm.
I actually get to go do that. I get to go see how lots of products are made. Like I saw how toothbrushes are made. I had no idea. I thought they just showed up in the store and you go and pick one.
Yeah.
And then in that entire process, there's, they're using air for cleaning, cleaning out the machines, things like that. But learning all of this stuff about compressed air, I learned actually how dangerous it could be. Like I thought it's just air. Like how could it be harmful or even deadly, in some cases. So like that's what really got me interested. And then I learn every day from someone, from something, from a customer. And then so it's the big safety part, but it also saves a lot of energy as well. So my passion is here. And then a month ago I met Elvira, and it's perfect. We have the same values. So
before we talk into more detail about your role and compressed air, I'd like to sort of ask the same question for Elvira.
So thank you, Paul. Can you hear me well? I hope
Yeah,
so.
we can hear you good.
Okay, perfect. Yeah, me and compressed air, the story started when I got passionate about thermodynamics at school. And then I continued my engineering. And then I did PhD in compressed air systems, in the efficiency of compressed air system. And I just found out while I was doing my research that compressed air is actually, let's say, not taken so seriously, the demand side, because people think that it's not efficient. But the problem is that the technology sometimes is not chosen correctly. And where there I started actually my optimization journey, and I got some experience in the industry. And after that, I decided to open my own company where I actually can help people to choose correct components and that using less air, less energy, and provide them tools to help. So we're creating tools, interacting, we're creating different calculators, software to show that efficiency is easy. So this is my passion and main idea, that efficiency has to be easy. It doesn't have to bring any headache, and it's all based on the on science, so people can trust me in my tools, equations, and science. So I think this is the main benefit of that.
And you have a PhD in compressed air, don't you?
Exactly. So you don't have to be scared to optimizing your compressed air system. So it's been proven.
So whenever I've seen a compressed air system, it's going off and on in the corner, making significant amounts of noise, and I can hear sometimes air leaks throughout the system, which is a bad thing, because compressed air is the most expensive form of energy that can be provided to a factory or a property, isn't it?
Yes, it's the most expensive. It's very expensive. I totally agree with you. And it has a lot of issues. But I think the main issue of the technology that it's very robust. So because it's so robust, it's going to work no matter what. So you have leaks, you have problems, you have cuts in the pipes or anything else. You just put more pipes in it and it will work. If we compare it with electromechanical systems, because I got a comparison of these both systems before. In electrical systems, you get a teeny tiny small dust, and then it just doesn't work. So it means you're obliged to keep your system in a good shape every time. And good shape, correct functionality actually means less energy consumption because you're using the system correctly. In compressed air system, the system is robust. It can work anyway. It means you are not obliged to keep it correctly. So it can create noise, and the people just getting used to that. It can be leaking. It can have a lot of issues, but you will still have functionality of your machine. So it will still work. And this is the main, in my opinion, this is one of the main issues.
Is providing the after sales service to a system once you've installed it. It's like anything, isn't it, really?
Yeah, I think so that maintenance system is one of the main services now in compressed air component side. So I think maybe Dani can also say like more about it. But what we're trying actually now to do is to show people that compressed air costs some money, and that you can make your life easier and you will not have any safety issues. But it's a bit hard, to change culture of it, because the culture is that hydraulics is dirty because of oil, compressed air is noisy because of air. Mm-hmm. So to show this new components, to show new benefits, to show other benefits than just energy savings, I think this is the main the main issue right now.
So Dani, we was talking offline earlier, and you was talking about the different tools that are making our life more efficient. Can you elaborate on that for the listeners today?
Yeah, so I wanted to tie in quickly your previous question about the leaks. So we actually found a study that someone did. Of course, every manufacturing facility is different. The size is different, the use is different, the quality of the compressed air lines is different. But for the leaks, so a big misconception is that the leaks they are costing you a lot of money, and it's just being wasted to nothing, of course. So that's step one. But the study that we found, and I can send links about it later, is that only about 10 to 15% of the compressed air usage is leaks. So where Sylvant can help, and where the energy nozzles can help, energy efficient nozzles, is the use side. And that's can be anywhere from 35 to 50% of how the compressor is being used. So yes, if you fix all your leaks, that's a small savings in comparison to the tools that can be upgraded to get the job done quicker. So the tools specifically for the compressed air case, a lot of people think of like pneumatic drills or things like that. So it's not actually blowing the air, but it's using it to run the tool. Mm-hmm. So those are it is what it is. It needs that much air to run the tool. The biggest savings possible on the demand end, so where they're using it in their process, is for cooling products, cleaning, drying, cleaning out the machine, anywhere they're using the air for blowing. So compressed air blowing, the different tools there are safety air blow guns. So that's a handheld gun that blows air. Why would anyone use this? Because it takes a really long time. So you have this intricate CNC machine, for example, or a milling machine, or any kind of machine. How do you get the little pieces or the dust or the debris out of that? Like, you're not going to take a broom and sweep it up. Like, you're not going to get a vacuum in there and try to vacuum it. It's impossible, and it takes so long. And production is about speed, getting it clean, effectively, efficiently. Even at water, you can't really use water because you have electrical components. So compressed air is really the only thing that makes sense to quickly get these machines cleaned or dried or moved. And it's very sanitary. Water can have all these different chemicals, or it creates rust, or slipping hazards, of course. So compressed air is really the best option, because people ask, why are they using compressed air if it's so expensive? Well, that's why. So the tools are the handheld air blow guns, air nozzles. So those would go on a pipe. So if they just have a tube blowing to get a part dry, it's using a lot of compressed air, or an air knife. So an air knife is just a series of air nozzles that just make a knife-like pattern. It's not a physical knife. So it's like a curtain of air per se.
So if we look at, I always like to look at projects, whether it's a new install or whether it's a retrofit, and we're looking at maintenance. So if we let's take the design side of it first of all, which I'm presuming that both the two of you can look at designing a new system from scratch.
Mm-hmm.
And then you could look at taking an existing system to enhance it, to improve the efficiencies. And then you can take an existing system to look at maintenance and better services, because we need to maintain the maintenance on those systems. Am I right in saying that's a process that we can follow from start to finish?
Yes, exactly. Yes, exactly. So, for example, for the maintenance side, there are usually a lot of issues with compressed air for the maintenance managers there. And one of the best solutions is the integrating decision support system, because we cannot expect everyone to know perfectly or to have a PhD in compressed air system. Trust me, it takes a bit of time to do that. So, and when we have maintenance manager on that side, we need to have a simple alarm system and not overflooding of data. So we don't need to have the cardio diagrams showing the flow and pressure levels there all the time, but a simple alarm telling him that, look, here you have now higher energy consumption. So maybe you have here high pressure drop and your filter is dirty. So you need to go and buy a new filter. And by giving this alarm, we actually can make also life of plant manager easier, because when he knows exactly which filter to buy and when to buy it, and when he's connected already with a component supplier of this filter, he can just easily purchase it. So, and this is the decision support system that actually can connect component suppliers and maintenance, as well as energy manager. This is, I think, one of the solutions. So that actually includes all components inside it, and not rather than some various softwares from various suppliers.
And is there bespoke systems out there that we can utilize to monitor the compressed air, or do they come part of the package?
Yeah, they usually come. So, for example, we develop our own system where we actually connect to any sensor. So it's not it's not connected to any supplier. So any supplier can just give the sensor and we can connect it. So there are, of course, the one monitoring systems that either serve for some components, certain components. Each component supplier also is trying to do some monitoring, or, for example, only compressor side. But of course, what is very important to have a holistic picture, because as Dani before said, sometimes we can have a nice, beautiful system, and then there are some efficiency problem, and people start to think directly about changing compressor or buy a new compressor. And what actually we need to think about is how to reduce demand, how to use it wisely. So rather than trying to change every single component.
And is it easy to go from A to B? For instance, when I'm walking around looking at a factory unit, for instance, I will identify that they've got a compressed air unit. Some of the things I would do, I would go to look at that compressed air unit when there's no work going on, for instance, at the end of the day or before the day has started, or even through the lunch break where all the machines are turned off. And I should expect for the compressed air just to be sitting there quietly, not trying to maintain the pressures. Am I right in doing that form of process, or is there something more intelligent we can be doing when we're walking around?
Well, there are several things that we can do when we're walking around. So I think the first thing is really we can see how we use. So when compressed air is, as you say, is like a sitting in the machine, and then the things like switched off. We just really can see if there are some leakages, because we can hear them. I actually had a very funny idea that sometimes we can put salami smell in the compressed air and have a cat walking there, and then they can find it is faster. And
That's amazing. I like that.
I don't know why no one is doing that. I don't know if it is animal welfare protection or I have my doubts. Do it for sure.
Elvira, I think that's an animal issue. I think you're going to upset
I would,
some animal
but my
rights
dog
people.
would do it, so this is, of course, the first thing, just to see leak. But what is the second thing to do is just, for example, we have a nice checklist on our website to check your demand side. So you go in first and have a look on the topology of the system. So if you have some places where you have tubes and you don't know where they're going, and you don't have any cranes like to turn it, to exhaust the air. So this is the first issue. So probably your compressor is working to fill up all these tubes as a reservoirs. So, and then the topology has to be mixed topology. So it has to be some ring around the ring line around the factory with the deviations to the machine. So no ring lines without any machines, without any use. So then we can go and check pressure levels in different points and see if there are pressures are very different. So if they're very different, it's a pressure drop. There is also the third thing that it's usually there is always something wrong with compressed air. Something is not working and it's not enough. So this is, of course, it's already, as we go to doctor, usually when we have problems, you need to go to specialist. But if the system works fine, we can start just with this general thing, leak hearing, also the compressor, checking the pressure levels on demand side. And then, for example, go just to your machines and see all the cleaning processes and blowing processes, which pressure level they're using. So if they use pressure level up higher than 4 bar, it's usually not correct pressure, or it's like higher than 5 bar, for example. And check what exactly you're using. If it is an open pipe, you can just already assume that your process is golden. So you just blow gold and money out of this. So probably you need to change this thing. So, and then after the demand side is more or less, let's say you say check for every single point of that, and all machines working correctly. Also check pressure level for the machines. And then you can already go to compressor and check the dryers, filters, and so on. So, but this simple checklist you can find also on our website and just get it and print it. You don't need to leave your email or anything. So it's just out there.
So can we, the compressed air system, is it the weakest link of a property? And we have got to constantly be reviewing it on a regular basis. We've got to keep on top of it, make sure it's kept tidy, clean, no leaks, etc., and well maintained. We've got to keep on top of it, haven't we? We can't just let it go in there and maintain it based on the condition of it. We've got to basically have a proper planned preventive maintenance program on it. Elvira?
Yes, sure. Yeah.
Question for you.
Yes, thank you. So for the maintenance, so there are usually maintenance programs in the in factories for that. Yeah. So, but what I really, so I would say there are two things. One is the personal things that maintenance manager like to do the way that they always been doing. So, and this is kind of a culture thing. And another thing, it is that what is very important to have, it's knowing your system very well, because sometimes there are managers also are changing, and this is another thing. So we actually have, usually there is a maintenance program. So, and usually there is, as I said, some software or services, for example, for compressed air people. So, and this is can really, let's say, make it make life easier. But the first and main issue, well, let us not say that this is issue. I don't want to say that people is an issue, but I think the main thing, it is actually the culture of just maintenance of the system. So as I told you, it works always, like really it can, I think systems, I think component cylinders have been 17 years old without changing anything inside. Yeah. So, and of course, there is a very good thing to also to say that component suppliers are making some very easy maintenance alarms. For example, some alarm like red, green, or you need to change sealing, or you need to check your pressure. So this is also helps a lot. But we need always to start step-by-step approach. So I'm always up to step-by-step approach, starting from the small things and really talking with people and energy managers, asking what they want, what they need, rather than bringing big pieces of papers of 50 pages from the head of the office and telling what is the next steps.
And then, so Dani, my views of this is now we install a system, we maintain it the best we can all the way through, and we keep recording the data, recording the operation of it, hours, consumption. And then we start calling on people like yourself to keep the tools working more efficiently, because I'm sure the tools are evolving regularly, bringing in new technologies, new ways of doing things to keep driving that energy cost down on that particular unit.
Correct. So actually, when I personally go walk a plant, I like them to be running. If I walk in and they're on lunch or break, I'm like, how am I supposed to see how the operators are using this?
Yeah.
So like I like to see them cleaning the parts, drying the parts, and you can hear it like across and I'm like, okay, who is blowing what in over there? And then we go there and see that they're using this giant pipe. Whereas if everything was off and there weren't people there, we would have never seen that, because they kind of hang some of the guns, or they do hide some of them because they're technically not. Here in the US, we have OSHA. Technically, they're not OSHA compliant, the bigger, open pipes that they're using, because they're technically not supposed to be using them. But we wouldn't find things like that if everything was off. So we're more, as you said, when production is up and running and going and in the process, are the pipes drying? Are they drying the part? Like, are they working? Most of the time they're not. So they turn up the PSI to get more force to it. So then they're just throwing more gold, as Elvira calls it. They're throwing more money at drying this one part. So it's interesting, but it's what people are used to. And like Elvira said, it works. So it is drying the part. So why would they change? So the demand side is a little bit more complex in changing, because you think air blow guns are easy. You swap them out. Once we get to the nozzles and the knives, it gets a lot more in depth. So the maintenance manager, you have to shut down production because they have to turn off the compressed air to go implement the nozzle onto the pipe. So they have to put a fitting on it, and then you have to angle it the right way, make sure we actually get quite a bit of information from the customer on every pipe that's blowing. So it's a lot more involved than just, update the compressor. So say I'm blowing off this pen and it's on a conveyor belt. How far away am I from this pen? Because the air expands and we don't want to waste air here and here. We only want to hit the part that we need to dry to use the least amount of air, but still get this pen dry. So it's like, how far away are you? What angle? How fast is this moving? Like, how fast do we need to get it dried in this amount of time? So it's a little bit more involved. What size pipe are you using? Did you just find a pipe in the back and it happened to be a 1/2-inch pipe, so you just plugged it in? Maybe you only need an 1/8-inch pipe or a 1/4-inch pipe to get that dry. So it's a lot more involved, and that's for only one blow-off station for this one pen. They could have hundreds of these stations cleaning, drying, cooling in the facility. So when we walk through, I walk the plant, with either maintenance or an engineer. Luckily, they know most of the stations that need it, and they can answer fairly quickly. But you have to go in and say, okay, we have about 1 foot. There's also, if we're putting a knife in the machine, we can only go back so far. So now we have restrictions that we have to get the nozzle to work, with the least amount of air that gets them the most blow force, that gets the part dry quickly, effectively, safely. So I think that's why a lot of people don't do it, is because, okay, yes, once we finally pick the nozzle, and a lot of engineers want to do things themselves. So they want to go on the website and just pick something, and then they just order it, say, and then they say, well, Sylvan, like, this is garbage, it doesn't work. And I'm like, well, how did you pick that nozzle? We have hundreds. And they're like, oh, well, we picked the one that has the less amount of air usage. Of course, we just picked that one. And I'm like, well, that one is a micro nozzle the size of the end of your pen. So of course it's not going to dry this off. Yeah. So of course it's not going to work. So it's a little more involved once we go to do that. We try to keep it simple. Like on the Sylvant website, we narrowed it down to 8 questions that we need answered in order to make a recommendation. So we try to simplify that, but trying to do it on your own without knowing all the different nozzle options. And we do customs also, so like custom air knives and things like that. So it's a lot more involved than...
It's a bigger story than what we think.
I think. Yeah. Yes. And people are like, oh, it's just easy. Just update all your nozzles. And I'm like, excuse me, like, I don't think you know how much work that is. Like, collecting all of the info we need, then shutting everything down and putting the nozzles in, and then adjusting the PSI so they work.
So you've just mentioned information, and for me, it's data. What data, and this is for Elvira, and I'm sure you've got the solution for this. What data can we get from a compressed air unit that's going to be of value to it? Do these units, or most of these units, do they collect their own data that we can use?
Yeah, for that we actually have a simple questionnaire and a wonderful tool that calls Excel to collect the data from the engineers, because they really like it. Paul, it's really easier than we think. So to do the preliminary analysis that we usually do, we just need people to answer some questions. And the first question is, do they actually understand for what they use compressed air? And from that point, you already can go further and to see, for example, what are their applications. And then we developed also calculation tools that also completely free for engineers. So, and they can just go and calculate, for example, if it is correct cylinder for my application or not, or is it correct pipe that I choose for that application or not. And in terms of data, it would be, of course, it's good if there are some sensors installed already, and you can just read some information about the volume, flow rates, pressure levels, they usually but for us, it's enough to know what kind of the machine, the topology of the system, so basically layout of compressed air line. So we can just see the layout of compressed air line, what types of the machine there, pneumatic diagram of the machine. It's usually always in technical data, and on which pressure the machine works. So also other applications, nozzles, vacuum, cylinders. So this is the main consumer. So basically we just need information about geometry of consumers. And when knowing geometry of consumers, so type or just a simple like material number plate, we can check on the component supplier database and already know how much. We can not even checking, like we can just calculate it. So we can just calculate approximate consumption of the factory, and usually it's really nice. Like it correlates with reality, then everyone is surprised and like, come on, it is physics. You can just calculate consumption of this kind of things. And then we start to speak with engineers and we actually see for what it used. For example, in 90% of actuators are oversized, and everyone knows it. Why? Because it's also a human factor, because like bigger you get, safer you feel. It's like, okay, like I'll just get the giant cylinder and for sure it's gonna work. So, but you can just get much smaller. And the first part of it, what we have, it's simple tools, for engineers. Like, look, you have this mass of 2 kilos to move from A to B. The machine works under this pressure. Check if it is correct cylinder that you used. And the engineer calculates like, oh, I can use it actually smaller. And then it shows also your savings. Like I use this now, I will go now to the lower diameter, and I actually can save so much and it's still gonna work. So the same also for nozzles, the same also for vacuum applications. So basically it is always the question of choice, correct choice, and trust. So this is the thing. And in terms of collecting data, topology of the system, if there are any sensors, any readings from sensors, and how exactly the air is used. And of course, which country you're from, so just to calculate how much you pay for that.
Yeah, different rates.
Exactly.
So is there anything that we can be doing now? So as of now, what can our building owners, factory owners, compressor systems owners start doing as of tomorrow morning when they go into their properties and they've got this compressed unit sitting in the corner? What can we be doing today?
What we can do today, I think first thing, it's awareness and education. So from my side, it's very important to show engineers, because actually engineers are deciding how to change their system, and maintenance managers. And we think, CEO decides an energy and manager manager. No, they always trust their people, and it's normal because it's engineer who runs the factory and who helps, who makes the process work. So I think the main thing is to talk with engineers and do some educational courses for them, and to show actually what can be done and how it can be saved. So the other thing is also to transmit, let's say, some simple tools, some simple calculations, and this kind of initiative. And I think what is also very important, when people already start to trust and kind of like build this respect towards some calculations and like physics, and actually that you can change something in your system, not overflood people with the data, but rather than giving step-by-step approaches. So I would say first one is education, like a simple 2 hours webinar, what can be done, what's been done, or for example, good use cases. We have use case where we saved 80% of energy consumption. Can you imagine this? 80%. No one believes me, but I swear we did it. So yeah, 80%.
I can see that.
And it's really normal for compressed air, because as I said, it always works. So first one is, let's say, not have too much pressure on the engineers on that, and just show them that this is possible, and then show tools how it is possible. So, and this is the thing, and maybe just to connect them in some kind of a network where they can share their feelings and their thoughts about it. Because honestly, Paul, we have all tools, we have competences, we have great people in the factory that want to change, that also are interested, but we need to connect them. So, and I think this is in fields like that. So tomorrow I will say, let's go and see webinar about compressed air, how it works, what you can do there. Go click there and just calculate things. Yeah. So just to have an idea how much you can save, because the moment you start to show people how much you can save, and only to get some also make work of your maintenance managers easier, how much, for example, a simple decision support system can bring to your factory. So this has already changed a lot, and people really want to improve their production. So it's some say that it's all about that they don't want to do it, but it's not true. So people really want to change it.
So Dani, is there any more we can add to that regarding the demand side?
Yes. So one thing you can do tomorrow is pick one application. So pick one, like the largest one that you know is using a lot of air right now. Pick one, answer the 8 questions, or just reach out and say, Dani, this is what I have, and get a nozzle, plug it in, see if it works. Even for just updating one nozzle, if you don't change anything, so you don't even change the PSI, you don't do anything else, you plug the nozzle in, depending on how much it's using and what you were using, it could be thousands of savings with just that one nozzle. So my thing tomorrow, pick one, like just anyone, pick one and try it. Like if it doesn't work, okay, we wasted a little bit of time, but if it does work, you save thousands of dollars, you improve the process, the safety, noise, or creating less noise. And then once people see that one application, then they're like, okay, we need to do this everywhere and at all of the other plants. Yeah. So it's literally just picking one. Like, I'm not saying you have to go do your whole plant tomorrow. Just go to one machine.
One step at a time. Like
Yeah,
that.
exactly. And just so you can gain confidence in the trust that Elvira said, like, okay, Dani, I trust you. You did what you said you were going to do, that you trust the products,
Yeah.
you trust the process. So I think that's very important as well.
So Dani and Elvira, um, I we come to that stage where I like to put you guys on the spot. Well, you've been on the spot all the time, but you've done really amazing regarding what you've been coming through, and I've learned a lot about the compressed air side of it. And I just thought it was just I didn't realize much about the demand side and the benefits that could be secured there, and I didn't realize how much maintenance and studies were going on in the background. I didn't know you could get a PhD in compressed air. So I'm very very inspired by this today. So, but just lastly, as you know, I like to put my guest on the spot, and you have been on the spot because you didn't even know you was going to do the podcast today. I've pushed that on yourself. Elvira was really up for it, but Dani wasn't too sure. But thank you for sort of really biting the bullet and coming on and really finishing this with me. So you're on the spot. I would like to ask them my last question, and what can you give back to our industry today? And we'll start with Dani because she's smiling.
What can we give back? I think we can give back, that trust and get rid of this burden that people think they have to figure these things out alone. Like, hey, there are people who are experts, that can help, and it doesn't have to be this huge process. So the giving back, we're doing the education, just making things aware. And even if you don't use a Sylvant nozzle per se, and you don't use me, what I can give back is still the knowledge. Use a nozzle, use any nozzle, something to improve the process, for all of the workers there, for the world, for energy savings. There's a lot of pushes to be green, just to do something. So my big thing is giving back on LinkedIn, raising awareness. I try to do it in different ways to keep people interested. But it's real, and I think we can not put so much pressure on ourselves or be embarrassed of what we're using because it's so old or out of date. Like, that's what it was at the time. So just knowledge, positivity is what I can give back today, and just do something today that your future self will thank you for. And that's what I put on my LinkedIn as well, because it resonated with me. So that's what I'll leave you with.
Brilliant. That's excellent. And then Elvira?
Well, from my side, I think it's not very far from Dani. I think it is a competence and inspiration. So this is two things that you can give to the industry. And as I told you, I really started, and I'm still doing a lot of free of charge, free of subscription email things for engineers to show them that what is possible, how you can calculate things, how you can use nice tools, and just to save a lot of money for your factory and just to make the process more efficient. And of course, that inspiration that it's possible. I mean, compressed air, it's a great field now where we can save enormous amount of energy and just to make the world a better place. So, and this is, I think, the most important thing. So we need to start really there to see how we use things instead of just trying to change small parts to be them like more efficient. So I think that the competence, and don't be afraid to connect with experts and just to see what they tell to you from different fields, not only compressed air. Just go and ask questions, please. It's normal. So
and engage with the experts.
Exactly. So we're learning. It's our lifetime is learning.
I am an expert, but I'm still engaged with the compressor expert, and I think that's important as well. We need to also, all the experts around the world need to come together, which is my mission, to bring energy experts together around the world to share knowledge. And that's the reason for my podcast, to share knowledge around the world. If just one person listened to this today and reached out to another expert, it'd be perfect in my world. When you guys approached me and I see the word compressor, I thought, wow, I need you guys on the call. We need to sort of push that knowledge out. So thank you very much for reaching out to me personally. I'm really pleased that we managed to get together and put this podcast together, and I hope this does add some value. And I'm sure this journey is just beginning. So thank you very much for both of you joining me today.
Thanks for having us.
Thank you so much for your work that you are doing. It's very, very important.
Yes.
We're happy to be part of it.
Brilliant. So there leaves me one more thing to say. Be safe, both of you and your families.
Thank you. You as well.
You as well as listeners of your podcast too. So.